So welcome back. This is our second video, video B, in the Introduction to Data Visualization. We're going to talk about who we're designing for, whether it's researchers or stakeholders, what kind of data literacy skills they might have, what other considerations we need to take into account, and then we'll have a mini example where we'll look at what's actionable in a hypothetical dashboard. So when we're talking about different kinds of dashboards or visualizations, we need to be thinking about who we're designing for because the needs of researchers are going to be very different from the needs of everybody else. And within that big umbrella of everybody else, we have, teachers and learners and parents, principals and guidance counselors. All of these people are going to probably have different kinds of experiences with data and different knowledge levels about what's appropriate pedagogy, what's appropriate, motivational strategies for working with students. So we need to know, that kind of information up front. And that's where we're going to start today is with a know your audience, right? And we're going to talk specifically at first about their data literacy. We're going to look at students and teachers and researchers. And then I'm also going to pull from a study of American physicians, because what we're going to see is that, while things might be better in other countries, in the United States, we do have a problem with data literacy. And we have to keep that in mind as we're coming up with visualizations. So if you go to American high school students and you give them a probability problem, one of the things that you're going to find is that this is not something that we have very effectively taught in this country. So here's an example that we've seen in the literature where they gave a bunch of high school students this setup. Suppose you are playing a carnival game that involves flipping two balanced coins simultaneously. To win the game, you must get heads on both coins. What are your odds of winning the game? And approximately half of the 12th graders, so last year of high school in the United States, last year of compulsory education in the United States, believed that there was a 50% chance of winning the game because that's what we've learned chance is for the most part in this country. Right? Now, again, if you actually look at two coins and what the options are 25%. So they did not understand how to effectively gamble, which is perhaps very advantageous depending on what kind of business you're in this country. If you're running a casino, it's really great news. But for the rest of us, maybe we want to do a little bit better about educating this, and definitely we want to take this into account as we're presenting data to students. If even our 12th graders are struggling with this, our 5th and 6th graders are going to have trouble with it as well. Right. We've also seen that teachers have trouble with these issues. And so we have a research study here from 2022, so very recent, that asks teachers to make estimates with fractions. And they wanted them to do estimates with addition and estimates with division. What they found was that most teachers couldn't do both, right? So a fair number of teachers could give an answer in the reasonable range for mixed fractions if you were asking them to do addition, but that number dropped pretty substantially if you asked them to do division. And the number of teachers that could do both was even lower, right? So this is the 45% rate here. Less than half of teachers who were teaching fractions at that point were able to do this. Now, for people that grew up with the American system where percentages, um, you know, 50% is a reasonably good chance and 80% means you've gotten a good grade, uh, people don't always visualize how this plays out, right? And so we've got a couple of visualizations that may be good, they may need a lot of work, but they're geared to understanding what this means in the real world. So assume that you're in a very large school district where there's 300 math teachers in your school district, right? If only 45% of them um, are able to do these estimates, then that's that. Think about how many students that is who aren't going to be able to be taught by somebody who's capable of doing both, right? It's this number over here, both the yellow and the red are the teachers that can't do both. If you're in a very small school district, it might be 10 teachers in your school who teach mathematics and teach fractions, or it might be 10 teachers in your whole town. And, we're looking at an even smaller number of people who are able to handle this. And, that's pretty frightening to me as somebody who has a kid who's in the age bracket where we need to be learning this. We definitely need to do better. That said, I don't want to sound like I'm picking on students, and I definitely don't want to sound like I'm picking on teachers. They have very, very difficult jobs. And so, what we want to think about is okay, who else could we compare this to? And I know from personal experience that researchers have a lot of trouble estimating problems with fractions and probabilities. So, I was on a project a number of years ago where three researchers were asked to independently code phenomena. So we had to say, yes, this thing is here, no, it's missing, or oh, I just can't tell from the data that I've got. And the resulting data showed that they had 60% of the codes that were either in full agreement. So everybody said yes, everybody said no, everybody said, I don't know, or partial agreement, so 2 out of 3. So two people said yes and one person said no or question mark, and vice versa. And a senior researcher in the field that I was working in at that point said that they thought this was a good level of agreement because 60% was above 50% and 50% is chance. And that was what he knew about statistics. Again, if you walk people through this, then they can kind of see it. If we start with 27 different combinations, right? So 27 rows of what might happen, 3 yeses, 3 nos, 2 yeses and a no, a yes and 2 nos, and so on. Um, then we can sort of highlight the ones where there's complete agreement, right? There's 3 of these 27 where complete agreement can happen. Um, there are 18 that occur where there's agreement among 2 out of the 3, and there will be 6 just as the base rate, right? These are possible options that you can get where there's no agreement at all. So the base rate for good agreement here, for chance agreement, is around 87% if we're doing agreement as 2 out of 3 or 3 out of 3. And we were only at 60%, so we were actually well below that. Okay. And then finally, we can pull literature that shows that we have this issue even among practicing physicians in the United States. So in 2007, they gave 160 practicing OBGYNs the following information about breast cancer. And they say, assume you've conducted a breast cancer screening using mammography in a certain region. You know the following information about women in this region. The probability that a woman has breast cancer is 1%. That's your prevalence. If a woman has breast cancer, the probability that she tests positive is 90%. That's your sensitivity. And then if a woman who does not have breast cancer, if the woman does not have breast cancer, the probability that she nevertheless tests positive is 9%. And that would be your specificity if you're used to looking at those statistical charts. Right? Well, what they found was if they gave 4 choices, about half of the doctors said that the probability that the woman had cancer was at 81%. 10% of the doctors said that out of 10 women with positive mammogram, about 9 will have breast cancer. 20% of the doctors said that out of 10 women with a positive mammogram, 1 has breast cancer. And 19% of the doctors said the probability that she has breast cancer is 1%. So then they went back and retrained the doctors and reframed how they presented that information. So they said, assume that you've conducted this breast cancer screening and you know that 10 out of every 1,000 women have breast cancer. Of these 10 women with breast cancer, 9 test positive. Of the 990 women without cancer, about 89 will still test positive. And when they presented it in that fashion, then 87% of the doctors got it correct. So again, Doctors presumably have to take a statistics class to get through medical school, but a lot of places in this country, they only have to take one. And so you can imagine that for some people, that might not be sufficient to catch something that is a little subtle and that is, likely to trip up people that, that work with this information if they don't actually stop and make themselves think about the prevalence problem before they get started with the problem. So we said, first we need to talk about the audience's data literacy. The other thing that we need to think about is their agency. And when we talk about agency in this context, we mean their ability to act to affect change. So, students and teachers and researchers are going to have different amounts of control over the learning situation. Um, if you want to define agency, what can I control? The too long didn't read version is me, basically. I can control myself most of the time in certain situations. We'll leave it at that. If I were an able-bodied middle-class student, right, I can control what goals I set, what readings I decided to do, how much additional information I went to look for, how much effort I put into all the assignments, and whether or not I reflected on how I was working, whether or not it was effective, and potentially how I'm responding to feedback. I might not be able to control much else, right? So how much I interact with other teachers and students is, somewhat dependent on those other people. How reasonable the course assignments are as a student, that's not in my control. And certainly, the last few years have taught us that things happen in the world that make learning very difficult and can make, unexpected challenges emerge. The COVID-19 disaster is still having consequences that, a lot of us couldn't control. As a college professor, I have a little more control over some things, so I can control what readings and activities are assigned, how the assignments are structured, what feedback I provide to the students, and so on. But I can't control whether or not the students feel that the readings and the assignments are important, or if they feel safe getting and providing feedback. I have some indirect control over that and how I approach it. But whether or not we have shared background or shared values, whether or not they accept my feedback, how many natural disasters happen over the course of the semester, those sorts of things are just not in my control. I have no agency over them. And as a researcher, in some ways we have control over parts of the learning systems that we're working with, and we can indirectly influence students and teachers by how we display the information and whether or not the teachers feel like it's useful information. But we can't really, right, control the data literacy, the knowledge, or the motivation of the people that we're telegraphing this information to. So what does that mean for data visualization and design within the learning analytics community? If a student sees that they've done poorly, they may or may not know what to do to get better. Right? A lot of them, if they were already motivated, would have done better if they knew how. Just giving them feedback on their assessment scores is probably not super useful. If a teacher sees that a student is doing poorly, they might have a little more experience to know how to approach that student. And so that formative assessment or that summative assessment, if it's coming early enough in the semester, is still really useful, but it may still need contextualization in order for them to fully make use of that information and know which pedagogical approach to take. So to summarize, we need to be careful that our data visualization is targeted at the data literacy of our audience, and we need to make sure that we're picking data that's actionable, right? To do that, we need to understand what agency people have over their environment and over their learning experiences.